This is the first lesson of Calculus AB. We are going to introduce limits. These are the four things we are going to kind of cover today about limits. Now, what is a limit? A limit, in particular, is the y value. So whenever we're talking about limits, you're always looking at the y value of a function as it gets closer and closer to an x value of our choice. And when we are looking at this x value, we look at it from both sides, coming from the left and from the right. For example, if we look at this first section, this is saying what is the limit as x gets closer to 3. So here's your x-axis. And as we approach 3, what is the y value doing of the function? And here it says that it's equaling 2. So in particular, as we get closer and closer to 3 from the left side and closer to 3 from the right side, what y value are we approaching? And in this case, it is 2. So just to make a note, this is the y value. And x equals 3 as we approach it from both sides. Now notice that we are not defined at 3, like the value at 3 is undefined because it's an open dot. But that does not matter. We're just looking as we get infinitely close to that value of 3. So like when we zoom in, and if we can keep zooming in and we get closer and closer to the value of 2, we don't actually care what it equals at 2. We're just looking at what it approaches to. Same thing here. So if you notice, this says what's the limit as x approaches 3 of g of x. So again, when we say approaches, we mean as it gets closer to 3 from both sides. So as we travel this way and this way towards 3. Now look what happens with the function. We are getting closer and closer to this value of 2. And again, we don't actually care what the value is at 3, because if you look at g of 3, that equals 4. Right? The value at 3 is 4. But we don't care. We're just looking at it as we approach 3 from both sides. And lastly, this is the same thing. What happens as we approach 3? It looks like we're getting closer and closer to 2. And the value is 2. So these are kind of 3 little cases. Again, and when you see this statement, we read it as the limit of f of x as x approaches 3 is 2. And again, this means this is the y value. All right, so if we go here, so let's see what happens. Let's look at graph, example 1. Part A, the limit of g of x as x approaches 4. So we'll do this one in purple. So we want to know what happens when we approach 4. Well, if we go this way and this way, both of these values from the left and right side are both approaching this value of 1. So we will say that this equals 1. Now, this is very, very important in particular when I say both sides, because we'll see with this next example. Oh, oops, I wrote this in the wrong spot. Sorry, this goes there. My bad. So now this one. So we're going to approach 1 from both sides. So as we approach 1 from the left, it looks like we're getting closer and closer to a y value of 1. But notice what happens when we approach it from the right. This value approaches 4, y equals 4. So which one is correct? So when we approach x equals 1, going to the right, it equals 1. But if we approach it going left, it equals 4. So since these do not match, we say that the limit does not exist. D and E. Next, so a lot of students will say, oh, we're doing limits here. No, there's no limit. This is just asking you, what's the y value at x equals 4? That's what it's asking. What's the value at x equals 4? And that is this value of 2. Okay, lastly, let's do this one. As we approach 2, and again, we have to go from the left and the right. And it looks like they're both approaching a value of 1. And again, this is approaching x equals 2 from the left and the right. Now, one-sided limits are just like what they sound, like what they say. It's actually just caring about one limit, one from a certain direction. So in our last example, when we did as we approach 1 from the left, our value was equal to 1. And that's what this terminology means. This means from the left. It doesn't, and again, I put this here, it does not mean that you are moving left. That means you start from the left and go towards the right. So you're approaching from the left-hand side. And then from the right, you denote with this little positive symbol right here. So when we approach from the right, we are going to equal 4. Y equals 4. So look at, these do not match. That's why the limit in this problem did not exist, because the left and right hand limit did not agree. Okay, for this next practice, this is just, or for example 2, it's just having you look at all these values. It's going to ask you limits, and it's going to ask you what is the value at a certain x. So notice, this right here means as you are approaching 3 from the left and the right, so they have to agree. Same here, as you approach 2. This one says as you approach 2 from the right. And if you look at this one, this is not a limit at all. It's just asking what's the value at x equals 1. So be mindful of that. So let's look at part A. We want to see what happens as we approach 3. So x equals 3. From the left and right, it looks like they both agree and that the value is going to be 1. Part B, what happens when we approach x equals 2? Well, that is here, x equals 2. Notice that if you approach from the left, it looks like it's getting closer and closer to 2. But as you approach from the right, you're getting closer and closer to 0. So those do not agree. It does not exist. And remember this one, C, what does this positive mean? This means from the right. So that means starting from the right and going this way. So what happens if we're approaching 2 from the right? That is going to be 0. And then lastly, what is the value at 1? So at x equals 1, what's your y value? That's what that question is asking, and it looks like it's going to be 1. It's defined at 1. All right, E. What happens as you approach -1 from the left? So -1 is here, from the left is going this way. It looks like we're getting closer and closer to the y value of 2. What happens when we approach -1 from the right. So if we go from the right, it's going to get closer and closer to -1. Now, this question says, what is the limit as x approaches 1 from both sides? Well, we did it here. This is from the left, it approached 2. From the right, it approached -1. So this one does not exist. And then lastly, what is the value at x equals -1? And it looks like there is nothing, because we have an open dot here and here. So there is no value at -1. So example 3, there's numerous answers here. It says write a limit statement for each criteria below. So you just want to find a limit that exists. So really, we can't do this one because the limit doesn't exist. We can't do a limit at 2. We can't do a limit at 5 because there's an asymptote. And then people will say, well, Mr. Busby, these both approach infinity. Well, yes, but that's not a number, right? So there's plenty of things we can do. I will do this one, the limit as x approaches 4 of f of x. So as we approach 4, it looks like we're going to get closer and closer to 1 on this side and this side. So this will equal 1. Let's do a left-sided limit and a right-sided limit. So I'm going to use this one for here and here. So the limit as x approaches 2 from the left, and again, 2 from the left means you're coming from the left and going this way. Looks like we equal 2. And then the limit as x approaches 2 from the right, if we go this way, it equals 4. And a limit that doesn't exist. Well, since I did this left-hand and right-hand limit, they're both approaching 2. That does not exist. So limit as x approaches 2. And the reason it doesn't exist is because the left-hand limit is 2, the right-hand limit is 4. Okay, so this was a multiple choice question from 2018 AP exam. So, what is the limit as x approaches 1? Well, if we go from the left, it equals 3. So that's from the left. If we go from the right, it equals 1. But since those don't agree, the answer does not exist. And there you go. There's your first lesson. Now, here's just some more problems. I'm not going to go over these. These were just practice. So, but if you look at here, it says translate that into words. The limit of g of x as x approaches -3 is equal to 6. It has some more limit practice. Here are the answers if you want to verify them. And then number 3 there's a big difference here. Notice these almost have the same verbiage. It's just this one has a limit and this one does not. So this means, what is the value of h of x as x gets infinitely close to a from both sides? It's a limit. This one just says, what is the value of function h at a? And then it equals c. And again, number 4, this is just one answer. It just says sketch a curve with all of these criteria. But again, hope this helps. Good luck, guys.